So you've probably been hearing a lot about this thing called the Model Context Protocol, MCP for short. Well, what if I told you that most of what you're hearing, the main story everyone is telling, is just plain wrong? Or at least it's missing the real point. Today, we're going to dig into what's actually going on with this tech.
Yeah, this quote right here, it just nails it. There's this narrative building up around MCP, and frankly, it's a little narrow. We're going to break down why that common understanding just doesn't capture the full picture.
Okay, so what is this big misunderstanding? Well, right now, if you listen to the chatter, you'll hear that MCP is this cool new way to kind of bolt on some AI agent features to your desktop apps. And, that's not wrong. It can do that. But if you're serious about building professional, enterprise-grade AI applications, that view is way too small. You need a much, much bigger vision, and that's exactly what we're going to lay out.
All right, before we can really appreciate why MCP is such a big deal, we've got to take a step back. We need to talk about the built-in problems with any large language model, right out of the box. Think of it like this. An LLM has this incredibly powerful but very lonely brain, and that brain has two huge problems.
So problem number one, just think about how you use an LLM. You give it a prompt, it gives you back text, words. And hey, if words are all you need, that's fantastic. But what if you want the AI to actually do something, to, take an action, make something happen in the real world? A standard LLM can't do that. It can talk the talk, but it can't walk the walk.
And then there's problem number two. The model is basically trapped in the past. It only knows about the data it was trained on. It has no idea what happened 5 minutes ago, let alone what's in your company's latest sales report, or even like a text file sitting on your desktop. For it to be truly useful in a professional setting, it needs a way to see and use current real-world information.
So this right here, this really lays out the challenge. On the one hand, you've got your base LLM that can only talk and is stuck in the past. On the other hand, what we really want is a true agentic AI. And to bridge that gap, our AI needs two things. It needs tools so it can take actions, and it needs resources so it can get live information. The million-dollar question is, how do we actually give an LLM these superpowers?
And that is where the Model Context Protocol finally comes into the picture. Now, it's not magic, it's not a secret sauce, it's an architecture. It's a blueprint. You can think of it like a microservice architecture designed for one specific purpose, to connect that lonely LLM brain to all the tools and resources it needs to stop being just a chatbot and start being a true AI agent.
So how does this thing actually work under the hood? It's actually a lot simpler than you might think. It's basically a client-server setup. You've got your host application, that's our agent, the client, and then you've got an MCP server, which is like this central hub that holds all the special powers we want our agent to have. And the two just talk to each other using standard web stuff like HTTP and JSON.
Now, the real secret sauce here is that MCP server. It's not just some passive chunk of code. It's an active service that basically shouts from the rooftops what it can do. It advertises its capabilities. It tells any agent that connects to it, hey, here's a menu of all the actions, the tools I can do for you, and here's all the data, the resources I can get for you. It's like a plug-and-play library of superpowers for any AI.
Okay, that's a lot of theory. It's probably a little abstract. So let's make this concrete. Let's walk through a super simple, real-world example to see how all these pieces, the app, the server, the tools, the resources, actually fit together to get something done.
So here's the task. A user types a totally normal, human request into our application. I want to have coffee with Peter next week. Now, a basic ChatGPT would just be stumped. It can't access your calendar, it doesn't know who Peter is. But our application, our agent, is powered by MCP. So let's see what happens now.
Okay, so here's the first move, and this is really clever. The application doesn't just blindly forward that prompt to the LLM. No. First, it pings the MCP server and says, hey, what resources do you have for me? The server might reply, I've got a calendar and a list of local coffee shops. Then the app bundles all that up and asks the LLM a much smarter question. It says, the user wants to get coffee with Peter. Given these available resources, like a calendar and a coffee shop list, what information do you need?
So the LLM thinks for a second and says, yeah, that coffee shop list would be super helpful. Great. The application goes and fetches that data. Now it goes back to the LLM for a second round. It says, okay, I've got the coffee shop list now. And by the way, here are the tools I have available, like a create calendar invite tool. What should I do next? See? Now the LLM has all the context it needs to make a smart recommendation. Like, you should use the create_calendar_invite tool with these specific details.
And this
This next part is maybe the most important concept in this whole thing. It's absolutely critical to understand. The LLM doesn't actually do anything. It doesn't execute the command. It's not reaching into your network and scheduling things on its own. I mean, that would be kind of scary, right? A little bit Skynet-y, as the quote perfectly puts it. All the LLM does is give you a recommendation, a suggestion.
Let me say that again, because it's the key takeaway. The LLM suggests, but the host application decides. The code running locally on your machine or your server gets that suggestion, and it makes the final call on whether to actually run the tool. This puts a firewall, a safety layer between the AI's reasoning and the real world. It keeps you, the developer, in complete control.
Okay, so we've seen the step-by-step mechanics of how it works. Now let's zoom back out to the 30,000-foot view. Because when you start building your AI systems this way, you unlock some seriously powerful software engineering principles. This is why MCP isn't just a neat trick, it's a huge deal for anyone building this stuff professionally.
You basically get these three amazing benefits. First is pluggability. You want to swap out GPT-4 for Claude 3? No problem, the server doesn't care. Second is discoverability. A new agent can literally connect to a server and ask, hey, what can you do? And immediately start using its tools. And the third, and maybe the most powerful, is composability. You can chain these servers together. One server handles calendars, another handles CRM data. You can build these incredibly complex workflows out of simple, independent pieces.
And that really brings us back to the main point. This is so much more than just a clever way to add features to a desktop app. What we're really looking at here is an architectural pattern. It's a gateway to building real, robust, secure agentic AI for the enterprise. This is how you move from playing around with AI to building with it like a pro.
So, when you break it all down, by separating the brain, the LLM, from the hands, the tools and resources, MCP gives us this incredibly flexible and powerful blueprint. It's a structured, safe way to let AI interact with the real world. Which leaves us with a pretty massive question to think about. Is this it? Are we looking at the fundamental architecture for how all serious enterprise AI is going to be built in the future?